Sketch the graph of the rational function. To sketch any graph, you would like to know the domain first. So we'll start with the domain of this function. For that, we will factor our function. We've got an x squared in the numerator. Factor that out and have an x plus 1. And in the denominator, we have x minus 3 times x plus 1. And for our domain for a rational function, we just can't have the denominator be 0. And so x cannot be 3, and it can't be negative 1. So we have our domain as all real numbers, as long as x is not equal to 3, and x is not equal to negative 1. Next, for a rational function, you want to reduce the fraction, because the reduced form is going to be a lot easier to work with. So here we've got an x plus 1 on top and bottom. We can cancel that out, and our reduced form is r of x equals x squared over x minus 3. Then we find the wholes using that reduced form. So the wholes are the numbers that we are allowed to plug into the reduced form that we are not allowed to plug into the original. And that usually just is looking at what we factored out, okay, what you canceled. We canceled x plus 1, and that means that in this reduced form, we are allowed to plug in a negative 1 for x. And so for our wholes, we know that negative 1, it will be the x value of a whole. And to find the y value, we just plug that into the reduced form. So r of negative 1 is 1 over negative 4. So that's negative 1/4. That's the coordinate of the whole. Next, we want vertical asymptotes. Vertical asymptotes. And vertical asymptotes we get by from the zeros of the denominator of the reduced form. So here's our reduced form. Our denominator here has a 0 of x equals 3. So that's a vertical asymptote. Next, we want our intercepts. All right, intercepts, we get our y-intercept we get by plugging 0 into the function. So r of 0, we can plug it in here to the reduced form, or you can plug it into the original. And r of 0 we get is 0. And so our y-intercept is 0, 0. And the x-intercept is the zeros of the numerator of the reduced form. And the 0 of this is, of course, just x equals 0. So it's that same point, 0, 0. And finally, we want horizontal asymptotes and end behavior. So, it may not be a horizontal asymptote. We may have a different type of asymptote or some type of other behavior to look at. So we start by looking at the degree of the numerator and denominator. And so we've got an x squared up here over an x there. And the degree of the numerator is bigger, and that tells us that we don't have a horizontal asymptote. Okay? However, the degree of the numerator is exactly 1 bigger than the degree of the denominator. So that tells us we do have a slant asymptote. And we can find that by doing long division. So we have x squared divided by x minus 3. We'll go through this long division to find the slant asymptote. So x times x will give us an x squared. We multiply the x by the x minus 3, so we get x squared minus 3x. And then we subtract. And the x squared cancels, and we are left with minus a negative 3x. And then again, x times 3 will give us 3x. So we plus 3 there, and we multiply through 3 times x, and 3 times negative 3. And then we subtract. And that cancels out the 3x's for us, and we're left with negative 9, so positive 9. And we're done with our division here because this has a degree smaller than the divisor. And so this x plus 3 is a slant or oblique asymptote. Oblique asymptote. Y equals x plus 3. And now we are ready to sketch. So we're going to go ahead and put everything together, draw everything that we have, and then draw our graph connecting those things. So we have, first of all, a hole at -1, -1/4. And so we have -1 and -1/4 is right around here. So there is a hole. We have a vertical asymptote at x equals 3. 1, 2, 3. And there is our vertical asymptote. We have our x and y intercept is just 0, 0. And so go over here to 0, 0 and plot that point. And then finally we've got our oblique asymptote as y equals x plus 3. So that's got a y-intercept of 3 and then a slope of 1. And so something like this. Okay, now you'll notice that we've kind of gone off here, and this is, you gotta be careful when you're drawing because you want to make sure you kind of see all your different sections, and we're probably going to need kind of space up here. So what I'm going to do is actually change my scale a little bit, my Y scale, just to help us here. So we're going to cut it in half here. So 1, 2, 3. So we're going to go through this point right here, and then a slope of 1 now is going to go down like that. Okay. All right, so there are our asymptotes. And now we're ready to draw. And again, we're working in sections here. So we've got the section that's to the left of this vertical asymptote. And it's got to go through these points here. And so there's a couple of options here. We could follow the asymptote, okay, go through those points there, and then we could cross through and go up, okay, and follow. Or we could cross through and come down and follow. But, or sorry, not cross through, but we could bounce off, okay, and then go down. And so we need to know which that is. And so we just look at this 0, 0, and that came from the x squared, okay, which has an even exponent, which means it's got to bounce off of that point. So it bounces off, comes down, and follows. Okay. And then for the section to the right of this asymptote, we can't cross this axis. And so we've got to be following the asymptote up here, okay? And so we've got to be up here and then follow our oblique asymptote. Okay, we can't come down, we can't be down here because in order to follow the oblique asymptote, we would then have to cross the axis, and we don't want that. We can't cross the axis there. So this is the sketch of the graph of this rational function.